Good morning everyone. Today we will be studying the chapter atoms and molecules. Alright, so let's get into it. What are atoms? Alright, so atoms are the smallest thing you could imagine. Alright, smallest part of a molecule. Okay, we have all studied molecules. Everything has molecules. What is beyond molecules? There are atoms. Okay, atoms make molecules. Alright, so now we are going to the very smallest part of something, of matter. Okay, smallest part of matter is atom. An atom is the smallest unit of matter. What is matter? Solid, liquid, gas. All these are made up of molecules. These molecules are made up of atoms. Okay, atoms are the smallest. Atoms are the smallest. It consists of three main subatomic particles. What do you mean by subatomic? Now, beyond these atoms, what is made up of atom? Sorry, what makes an atom? That is protons, neutrons, electrons. These three subatomic particles make up one atom. So now what are these three subatomic particles? These are protons. What are protons? Protons are positively charged particles, so they have a plus sign over them, present in the nucleus. Okay, so you see this atom. This black outline is nucleus. Inside this nucleus is proton, neutron and electron. So inside the nucleus we have proton and neutrons. Okay, electrons are outside. So inside the nucleus we have positively charged particles inside the nucleus, that is protons. Neutrons, particles with no charge. Alright, they have no charge, so neutral, also found inside the nucleus. Electrons, now we come to electrons. Electrons have a negative charge. Okay, negative charge, orbiting around the nucleus. Okay, what do I mean by orbiting around? See, we all know earth orbits the sun. The earth orbits the sun. Okay, how? It goes like this around the big sun. It will go like this. Suppose this is the earth. It is going again and again like this around the sun. This movement is called orbiting in fixed fashions, orbiting the nucleus. Okay, so these orbitals are also called energy levels or shells. Okay, this is how this electron, see this electron, it is moving in orbital around the nucleus. Alright, so remember, this is the nucleus. Inside the nucleus we have protons that are positively charged. Inside the nucleus I also have neutrons that are neutral. Why neutrons? Neutral, no charge. Okay, electron negatively charged. How? It is orbiting around, going like this. Another electron going like this, another electron going like this. Alright, so it is not inside the nucleus, it is outside. Okay, how do we have an atom? Since protons are positive, electrons are negative, neutrons are neutral, so positive plus negative make up a neutral charge, and since neutral charge and neutrons are already there, that is how an atom is stable. Okay, it is stable. Now we come to constituents of an atom. Alright, so constituent of an atom. The constituents of atoms are subatomic particles, protons, neutrons and electrons. Okay, protons have a charge of +1. Like I told you, it has a positive charge. The charge is now numbered, it is +1. Also we have the relative mass. Okay, the mass of each proton, electron, neutron, these are measured in atomic mass unit. For example, distance is measured in kilometers, but mass of subatomic particles is measured in atomic mass unit called AMU. Okay, this will give us the mass, how much mass it has. Alright, the relative mass of approximately 1 atomic mass unit. So proton has 1 AMU with a charge of positive plus. Neutrons, they have no charge, neutral, and a relative mass of approximately 1 AMU. They also have the same mass. Electrons have a negative charge and are considered to have negligible mass. We do not calculate the mass of electrons. They have negligible. We can ignore for right now. Okay. Atomic number. What is atomic number? It is an important term. What is atomic number? There are a lot of questions that you will get on atomic number. The definition of atomic number, identifying the atomic number. They might give you an element and they might say what is the atomic number of this. For example, what is the atomic number of chlorine, what is the atomic number of oxygen. Alright, so atomic number, which is denoted by Z of an atom, is equal to number of protons in its nucleus. Simple. Atomic number is what? Number of protons. Okay, what were protons? They were positively charged subatomic particles. Where were they? In the nucleus. So how many protons will give you the atomic number? Z. Simple. The mass number. Mass number is denoted by A. Alright, you might think, why is it not denoted by M? No, it is denoted by A. Around the globe, internationally, it is denoted by A. Okay, same goes for atomic number. It is denoted by Z. Now, the mass number represents the total number of protons and neutrons present in the atom's nucleus. Alright, so atomic number was only protons, mass number was protons and neutrons. Okay, so supposedly this was the nucleus and this was, dark ones are protons, light ones are neutrons. Okay, just consider it. For example, if I want atomic number, I will only count the dark ones because they are protons. If I want mass number as well, A, I will take all of these into account. Protons plus neutrons. Alright. Most mass of an atom is in its nucleus. Okay, so the major part of its mass is in its nucleus. Alright. Since an atom always consists of positively charged protons and negatively charged electrons, hence the net charge on the atom becomes 0. Like I told you earlier, let's go back to this diagram. The net charge, since this is negative, these are positive. Okay, just count this. Count the red ones. 1, 2, 3 protons. Okay, 3 protons. Okay, that is plus 3. 3 electrons. 1, 2, 3 minus 3. What is net? 0. We add plus and minus, that will result in 0. And neutrons have no charge at all. So again an added 0. So this is what makes an atom stable. So most mass of an atom is in its nucleus, and atom consists of positively charged protons, negatively charged electrons. This is what makes net charge 0. Okay, if it has equal number of protons and electrons, it is 0. Net charge is 0. Now we come to atomic mass. Now atomic mass is also important. Atomic mass of an atom is the weighted average mass of all its naturally occurring isotopes. It is the weighted average mass of all its occurring isotopes. Okay, so what are isotopes? We will get into it. what is atomic mass? It will be cleared from it. Atomic, just remember the unit, atomic mass unit is AMU. Okay, atomic mass is typically slightly greater than the mass number due to presence of isotopes. Okay, so what are isotopes? Isotopes are atoms of the same element. Suppose I have hydrogen. Okay, hydrogen is an element. You might say this is the only atom. No, hydrogen is found in many forms that are isotopes. Types of atoms, isotopes. Alright, basically isotopes are atoms of same element which have same atomic number but different mass number. Atomic number, protons, they have the same number of protons inside them, but the sum of protons and neutrons will be different. Okay, so same number of protons in each isotope, but since it has a different number of neutrons, the mass number will be different. Okay, so isotopes, same atomic number. Okay, Z is same, but A is not the same. Z is same, A is not the same. So for example, consider hydrogen. Alright, deuterium has mass number 2. Alright, it has a mass number that is A2. You will see atomic number is same. Okay, atomic number will be same for all, that it has only one proton, but the sum of neutrons that are added will be different in each. Okay, so in deuterium we have one proton and one neutron, so it makes a mass number of 2. So it has 2 mass number. Okay, tritium, it has 3 mass number. Protium, having no neutron in its atom, okay, so it has 1, only proton, and 0 neutron. These are available in very less quantities in our atmosphere. Alright, now what was the atomic mass? Atomic mass is the weighted average mass. Okay, if I take the mass number of all of these and I do an average, okay, so supposedly 2 plus 3 plus 0 divided by how many are these? 3. What number I get would be the atomic mass. Okay, if I get this will be 5 divided by 3, it will be 1 point something. This would be the mass number, atomic mass, sorry, atomic mass. AMU, weighted average mass of all its naturally occurring isotopes. Okay, carbon, now come to carbon. Carbon with an atomic number 6. Okay, atomic number 6 means Z equals 6. Okay, number of protons is 6, but it has 2 more isotopes with different mass number, different added neutrons. Okay, so carbon, it is 6. Alright, but carbon 6 with what? 12 mass number and 14. 12, carbon 14 as well. Alright, so in this one it has minus the 6 protons, it has 6 more neutrons. 6 plus 6 is 12. Over here, minus the 6 protons, 6 protons and 8 neutrons. Alright, these are the forms in which carbon exists. Come to this. This shows atomic mass. Alright, if you see closely, hydrogen has an atomic mass of 1.01. Lithium has this much. Sodium has this much, 23. Carbon has 12. Alright, carbon majorly has a atomic mass of 12 AMU. Helium has 4 AMU. If I come to chlorine, important, 35.5 AMU. These are all important. Alright. Oxygen is 16. Nitrogen is 14. These are all atomic mass. Atomic mass. How much mass is the weighted average of their isotopes? Okay. What is this? This is the periodic table. It is like imagine a castle. Alright, and these are the bricks. Even if one brick fails, this whole thing will come crashing down. This shows all the elements that are here present on this earth. Alright, it shows their mass number, how many electrons are there, protons are there, neutrons are there, everything is represented by this. Over here we have inert gases. Okay, these will not react with anything. Okay, and why, we will come into that. It starts with hydrogen. Okay, hydrogen over here, helium over here, it goes like this. You will study about that in detail in higher classes. Shells. Now this is an important topic. What are shells? Electrons revolve around the nucleus in fixed orbitals called shells. Alright, each shell holds different amount of electrons in it. Okay, so supposedly this is the nucleus. Alright, I will color it. Around these will be electrons orbiting. Okay, so consider orbitals, but these orbitals also have levels. Alright, in each orbital, how many electrons are possible? So the first one we denote it as K. Other proceeding we denote by L, M, and another one called N. Okay, K, L, M, N. How many electrons can I fit in this K shell? I can fit only 2. This is the first shell after the nucleus. I can fit 2. Okay. How do I know? It is a formula for that. That is given over here. 2n square. Okay. What are these shells again? Electrons revolve around the nucleus in fixed orbitals. These are fixed, called shells. Each shell holds different amount of electrons in it. Each shell will have different amount of electrons that it can hold. Alright. And this will be given by formula 2n square. N is the number of shell. So K will be our first shell. Okay. So N will be equal to 1. Now you see 2 into 1 square. That is 2. 1 square is 1. 2 into 1 is 2. So I can have only 2 electrons over here. Proceedingly, now I have L. L is the second shell. So 2 multiplied by 2 square, that is 2 multiplied by 4, which is 8. So this L shell, you see, this will have 1, 2, 3, 4, 5, 6, 7, 8. Alright, spread in this whole circular format. I have just put them here. And these 8 is the total capacity. I'm not saying there are always 8 electrons in everything. Okay, but this shell can hold 8. Alright, this shell can hold only 8, not more than that. Now I come to M. M is the third one. So 2 multiplied by 3 square is equal to 2 multiplied, what is 3 square? 3 into 3 is 9, which gives me 18. So in this M shell, I can fit 18 like these. Okay, 18 electrons. That is the maximum capacity. And in N shell, 2 multiplied by 4. N is the fourth one, 4 square. 2 multiplied by 16, it is 32. 32. Okay, I can fit over here 32. Okay, a lot can be fitted in the outermost shell. Okay. Always remember 2, 8, 18, 32. This is the maximum each shell can hold. So for example, okay, now I will come into valency, which is an important topic. Okay, so remember now. Supposedly some element has 10 electrons. Okay, it can only have 10 electrons. Okay, so different elements have different number of electrons possible. Alright, so 10 electrons. How will the shell show how many electrons it has? Okay, this is the maximum capacity. Okay, so in the K, L, M and N, for I have to fit 10 electrons. The first one can only fit 2. Right, the first one can only fit 2. How many remain? 10 minus 2, 8. Okay, I can fit 2 in K. L has 8, so I can fit 8 in L. M and N 0 because no more electrons left. Now supposedly this was 11. Okay, 11 electrons. So K, L, M and N. 2, 8. Now 1 is remaining. 1 will come in the next shell because L can only fit 8. However, M can fit 18. Supposedly, if it was 29 electrons. Alright, let's go over here. Supposedly, some element had 29 electrons. What will happen? K, L, M, N. This can fit 2. This can fit 8. What are remaining? 19. This one can fit 18. Where will the other one go? 1 over here. Alright, 1 over here. 2, 8, 18, 1. This will comprise of 29. Alright, 29. Now, understand this. Valence electrons. Okay. We all atoms will try to achieve a stable state. Okay, they will want that all their shells be filled. All right, and I don't have to have one electron in the outside shell, one in the inside. Like, I don't want that. I want everything to be filled. How will they behave? Okay, electrons that are in the outermost shell of an atom, like over here 8 was the outermost shell. Okay, 8 was the outermost shell. Over here M is the outermost shell because one electron had to go in the M orbital. Alright, so electrons that are in the outermost shell are the ones that participate in the chemical reaction. Whenever atoms react, the electrons in the outermost or the farthermost shell will be participating in chemical reactions. Okay, so for any chemical reaction, always remember the ones in the outermost shell, the electrons in the outermost shell of the elements will be reacting. Okay, and this is called valency. Okay, how many electrons are required to achieve a stable state? How many electrons do I gain or I lose or I share so that this shell is either 0 or complete? Okay, this shell is 0 or complete, the outermost shell. Okay, this one is complete right now, so it is already stable. This one is not. This will want to lose one electron, and because losing an electron is easier for it than gaining more 17 electrons, right? So valency is defined as number of electrons lost or gained or shared by element in chemical combination. We will discuss this in detail. So hydrogen has a valency of 2. Hydrogen has 2 protons. Alright, 2 electrons. Sorry, 1 electron. Yeah, 1 electron in its outermost shell. So if this was H, this is its nucleus, there is only 1 electron orbiting around it. So what will it want? Now the first shell can hold 2 electrons. Alright, if it will lose this, it will have no electrons. So it wants to gain 1. Okay, so its valency is +1. Okay, helium has 0. Alright, cause helium has, He has in its outermost 2 electrons. These are 2 electrons. Okay, so neither does it wants to share, neither does it wants to lose. It is an inert gas. It will not react with anything. Okay, now we come to sodium. Okay, or magnesium for that matter. It has 12. It has 12 electrons. Alright, how will its configuration look like? 2, 8 and 2. Okay, now I know this shell can hold 18. Okay, but but 18 will be a lot of elements, so I will take only till 8. For example purposes, I'm taking only till 8. Suppose this can take only 8. All right, now 2 are already there. It wants to achieve a stable state, that all my orbitals are filled and this one has some lacking, only two electrons. So I will want to trade this, I will want to give these 2 electrons so that I have a stable state. All right, now this is a property of magnesium. It has a charge of +2. This is its valency, that it can donate, give out 2 electrons, so +2 to something that wants electrons. Supposedly some element has 286. It needs 2 electrons to achieve the total configuration of 8 over here. Okay, it had 6. Okay, if magnesium donates it 2, it becomes 8. It will also get stable. Magnesium will also get stable. So these electrons, okay, that are in the outermost shell are called valence electrons, and plus and minus depends on whether it is giving or whether it is taking. Okay, metals usually give electrons. Okay, so they have a positive charge. Magnesium, aluminium has +3, magnesium has +2, sodium has +1. This means in their outermost shell they have this many electrons that they can give to achieve a stable state. Okay, now in case of non-metals, non-metals are usually have a negative valency. Negative valency. How? They will accept electrons. Okay, chlorine has a negative valency. Okay, they have a tendency to lose electrons. These have a tendency to gain electrons. Here are some valencies that are important along with the element. So hydrogen has 1 valency, helium has 0, lithium has 1, beryllium has 2, boron has this much, carbon has a valency of 4. Okay, you will never find valency of 4 again except for silicon. Due to this property, carbon can form a long chain. Okay, that is why Earth is a carbon based life form. Why? Because there are a lot of carbon compounds present on this Earth. We are made of carbon. Why carbon? Because it has a valency of 4. Alright, it can form long chains. Also silicon, but we are not silicon based, we are carbon based. We are a carbon based life form. Everything is carbon. Okay, trees, the desk, the wood, a lot of things is carbon. Now we come to nitrogen. Nitrogen has 3. Okay, oxygen has 2, fluorine has, but these are all in negative. Okay, remember, -3, -2, -1, because these are non-metals. Neon is 0. Neon is again an inert gas. It will not react with anything. It has filled orbitals. Okay, its K shell, L shell, M shell, N shell are all filled. Okay, still M, I guess it is still M. There are 0 in N. Okay, for neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine -1, argon is again 0. It is an inert gas. Potassium +1, calcium +2. All right. Now also we have some important compounds. Carbon dioxide, magnesium oxide. This is an atom of magnesium reacting with an atom of oxygen. Alright, magnesium was +2 and over here you can see oxygen is -2. So +2 -2, this will make MgO. Similarly, Na was +1, Cl is -1. Okay, +1 -1 became stable. Alright, that is why NaCl. Now we come to some like interesting compounds. Let's go. Nitrogen and hydrogen. N had a valency of 3. Okay, if you go over here, nitrogen -3, 3. Hydrogen had how much? 1. So if I show you, let's go back. We have some empty space over here. N had a valency of 3. H had a valency of 1. They trade, like I told you. So compound will be from NH3. H has now 3. Okay, this goes H, this goes to N1. Now they both become stable and they formed a compound NH3. Alright, NH3. Similarly, H2O. O has how much? 2. Valency of 2. Hydrogen only had 1. Okay, so 2. 2 goes away, 1 goes away. Alright, HCl, hydrogen 1, chlorine minus 1. Similarly, HCl. Okay, see these compounds. Okay, see these compounds. NaOH. OH has minus 1. This is hydroxide ion. Okay, also ions are also formed and they also have valency. Okay, this is called hydroxide ion. Sodium along with hydroxide ion. Okay, hydroxide ion. How does it look? Sodium hydroxide. Sodium was plus 1. This one is minus 1. Let's go to the next page. What are molecules? Now we come to molecules. Molecule is a group of 2 or more atoms bonded together. Okay, so if I have hydrogen, it is bonded with chlorine. This makes a molecule. This is one atom. This is one atom. Okay, this makes a molecule. Molecules are group of 2 or more atoms. There could be more over here of different. Alright, remember different atoms. Also of same atoms, but that is called diatomic. Okay, so it can be composed of atoms of same element or different elements. Number of atoms present in one molecule of an element is called atomicity. How many atoms? Over here that is 2. So atomicity is 2. If this was 3, then 3. If this was 4, then 4. Simple. Alright, very simple. Supposedly H2O. How many in this? 3. Alright. Consider NH3. How many? 4. 3 hydrogen. 1 this. So 3 plus 1, 4. Right. Let's see over here. Molecules of elements. Okay. These are formed when atoms of same element combine. Okay. Molecules of elements. Supposedly 2 atoms of the same element, oxygen, oxygen, hydrogen, hydrogen, chlorine, chlorine, they combine to form a molecule. Alright. O2, it consists of, see, this is one oxygen. How many electrons? 2, 1, 1, 1, 2, 6. Alright. Over here also 6. They combine to form 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Alright. 12. What is O2? It is 12. Alright. If you remember the in the compound, in this molecule we have 12. Nitrogen, N bonded with N, that is N2. How many atoms? 2. This is diatomic. Di means 2. Diatomic. Alright. So atoms of same element combine to form hydrogen molecule. Now we come over here. Molecules of compounds. Alright. Compounds are formed when different elements combine to form one compound. Alright. So atoms of different elements. Okay. When atoms of different elements combine to form a molecule, that is called molecules of compounds. Okay, so earlier it was H and H, O and O. Now we have H and Cl. Okay, Na and O. So this is also molecules of compounds. For example, water molecule H2O. It consists of hydrogen atoms bonded to one oxygen atom. Alright, 2 hydrogen atoms bonded to one oxygen atom. Alright, what will happen? They form H2O. Okay, carbon dioxide molecule CO2. This is a molecule comprising of and 2 O's. 2 atoms of oxygen, 1 atom of carbon. Similarly over here, 1 oxygen, 2 H. Alright, this is how molecules of compounds are formed. These are different atoms, alright, of different elements, and they combine to form a molecule. Now we come to ions. Alright, like I told you, hydroxide ion. Alright, what is it? Ions are electrically charged, remember, electrically charged particles formed when atoms gain or lose electrons. Okay, so when atoms they gain or lose electrons, they will form electrically charged, because electrons have negative charge. Okay, so when they gain or lose electrons, they will form ions. So this is a hydroxide ion having a negative charge. Okay, this is a chloride ion. Okay, there are many ions, we will get into the detail. Ions can be positively charged, ions can be negatively charged. A positive ion is called cation, a negative ion is called anion. Alright, so chlorine is a negative ion. Okay, chlorine has anions, it forms anions. Sodium are cations. Always remember, metal forms positive ions that are called cations. Non-metals form negative ions that are called anions. The reaction between an anion and cation, okay, that will form molecules. Okay, so a positive ion and a negative ion, they have an ionic bond that is very strong, which is very difficult to overcome. So ionic bonds are mostly solid. Okay, so an ionic compound that is formed due to the presence of ions will be mostly solid. Alright, it would be mostly solid. Alright, these are ions. C, negative, positive. Let's go to the next slide. Now I have some compounds in which I have shown how many cations, which are cations and which are anions. Alright, simple. So in NaCl, sodium chloride, I have cations. Alright, Na plus. Over here I have Cl minus, anions. Alright, anions. Na plus, Cl minus. Cation, anion. Cation has a positive charge, anion has a negative charge. Over here ZNO. See, the metal has a positive charge, cation. Oxygen, a non-metal, negative. Okay, valency is 2, 2. Okay, one has plus 2, one has minus 2. FeF2. What is Fe? Iron. Iron has a cationic property, it has a positive charge. What is F2? Fluorine. Okay, it has minus 1, but 2 atoms combine to form minus 2 charge. Okay, it has a anion, it is an anion. Cations are positively charged when atoms lose electrons. Okay, since metals can lose electrons, okay, they form cations. Sodium ion, calcium ion, all metals will form cations. Okay, anions will be formed by non-metals. Alright, anions are negatively charged ions formed when atoms gain electrons. So since this had a dearth of 1 electron and this element will give him 1 electron, this was called as anion. Why? Because they will gain. Okay, they want 1. I showed them by negative. Why? Because they have a scarcity, they have less of that. By how much? By 1. Okay, so I show it minus 1. Alright, by minus 1. Negative, this is an anion. It is formed when chlorine atom gains 1 electron. Oxide ion, when oxygen atom gains 2 electrons. Okay, this is an anion. Okay, formulas and example. Now this is important. What are formulas? Atomic mass formula. Okay, atomic mass is equal to relative abundance of isotope 1 into mass of isotope 1 plus relative abundance of isotope 2 into mass of isotope 2. This is how I found atomic mass. If you remember, it was a weighted average. Alright, for example, calculate the atomic mass of carbon given the following isotopes. Okay, I have carbon 12, I have carbon 13, I have carbon 14. Okay, I have given the all the mass. Okay, now their abundance level. So I multiply this abundance by their mass, then I add this abundance by their mass, this much abundance in their mass. I add all of this. This number will be my atomic mass, AMU. You need not calculate this, but this is how we get the weighted average. Okay, weighted average. Formation of ions example. Okay, so I have a sodium ion, it has 11 electrons. So KLMN 2810 over here. When it loses one electron, since it has only one electron, it forms a positive ion. Okay, since it can lose one, okay, it can give. Let's not use the term lose, it can give. Alright, and something was chloride, it was 29. Okay, so or yeah, 29. Okay, now I want sorry 2 and 7. All right, it was 2 over here 7. I need 1 over here for to make it a compound. Okay, to make it stable. So sodium will give its 1 electron to chlorine, Cl. This was minus, plus, this plus goes here minus, it forms NaCl. This is how molecules of compounds are formed. They trade their outermost electrons. Okay, I hope you got this. It was an interesting lecture for you. This will be enough for today.